Hello, friends. We are back with episode 131 of the Our Weekly Highlights podcast. That just happens to be the name of a street I live by, so I guess I like the number 131. But in any event, we're not here to talk about streets, although we will have some mapping content later on. We're here to talk about the great R content that we're featuring on this week's issue of Our Weekly itself. My name is Eric Nance, and I'm so delighted you joined us today. And joining me on the virtual hip here, my MVP of this podcast, Mike Thomas. Mike, how are you doing today?
I'm doing well, Eric. It sounds like all the internet sleuths out there are going to try to figure out where you live. So best of luck using 131.
Yeah, because it's not like that's an uncommon street name, right? Yeah, that's an Easter egg for all of you out there, I guess, like your mapping adventures. But I'm not one of those. I just need to know where I get to from point A to point B and hope the GPS doesn't fail me because I am now very dependent on those, especially on long-distance road trips.
Aren't we all these days?
Aren't we all? That's right. And we also depend on awesome curators in our weekly because this week's issue was curated by Tony Elharbar, another longtime contributor to our team. And as always, he had tremendous help from our fellow R-Wiki team members and contributors like you all around the world with your awesome pull requests and other notes of encouragement. So let's get right into it with another fantastic post from a frequent contributor and former curator of our weekly. Our open size software engineer, Mael Salmon, is back sharing a tip that she learned that's going to help her minimize her use of the for loops. Now, I like to keep it real here on this podcast. I've had to read this post a few times, and it's not because of Mael herself. She is a tremendous writer. She does a terrific job, as always, with balancing the prose of her blog post with examples to follow. But this is a concept that isn't as intuitive to me yet. But again, this is one of the values of our weekly itself, where we can kind of challenge ourselves a little bit with new concepts to us and see how they apply to our daily work. And what Mael is talking about here is the use of a very handy function in the purrr package called reduce that can actually minimize the need for a for loop in certain situations. Now, what is this all about? Well, in her post, she talks about being inspired by a package development where she's updating a data frame and a specific column of a data frame, but that update value is coming from a, you might say, nested list or a very hierarchical kind of setup. And she has a function to actually do the update for like one row and one value of that column. But in her past adventures with this update, she had did a for loop to loop through those different items of that list to do the update and kind of rinse and repeat. Well, this reduce function from the purrr package is going to alleviate the use of that for loop, where now, by default, the reduce function will apply a function to this, item of list. Usually it's a list of things or maybe a character vector or whatnot. And then as it applies it to the first element, it's going to apply it again to the second element, but chain together or bring together the output of those first two, you might say, runs of that function, and then accumulate the third or remaining instances and kind of rinse and repeat. I'm probably doing a bad job of explaining this. That's why you need to read the post for it. But the part that I honed in on is with a for loop, I admit, sometimes it's a little more readable to me to kind of see what I'm up to. Maybe I need to tweak the function, but there is a bit of downside to it. For loops are going to be executed in the environment that you're executing that loop in, and maybe you're creating some intermediate objects along the way. Maybe it's like temporary data frames or temporary items, and then that's going to, I hate to say you pollute, but it is going to put more things in your global environment that you may not want to have. But with things like reduce and the map functions, you can keep all those intermediate objects in that custom functions environment, which can be handy for debugging when things go wrong. So that's one advantage of this approach. But then Mael makes use of what happens if you need to feed in like another constant in this function you're going to put reduce in front of. That's where you make use of the anonymous function syntax in later versions of R, where it looks like that slash, and then you put in the names of the parameters, and then you call your actual function where you can feed in the constant along the way. I don't know why. I'm still struggling with that kind of syntax. I've not adopted it yet in my current workflow, but the Mael's post was a very nice kind of way to advertise that first, for loop, there is an alternative to it if you're doing this repeated operation on a single object and you're kind of modifying things step by step in that object or data frame of interest. But also, this anonymous function syntax gives you a way to not have to always make a new version of that, you might say, primary function. But if you just want to put something in there in its namespace without redefining the function itself, you can kind of do that and then do things with this anonymous syntax to bring it along the way. I'm still not intuitive with this yet, but I think it's another kind of small advertisement to there's some nice hidden gems in these packages like purrr in this idea of not just like repeatedly executing a function on a collection of items in a list or a character vector, but when you have to make updates to an existing object, which can be quite common as you're getting like rolling data or rolling information, and you have this maybe you might say a central data frame that you want to keep these updates in. Instead of making temporary copies along the way, this reduce function can be a nice way to assemble that all together. Hopefully I did that some justice, but I definitely invite you to check out Mael's post for the full example and see how that might help you minimize your for loop usage. So again, great job, Mael, for giving us a little peek behind your development curtain. And certainly I'm intrigued to see what you learn by using reduce and other helpers from purrr going forward.
I'm not going to lie. I really try to avoid for loops in general. And sometimes it leads to me taking like an hour to figure out a purrr way to do something that I could have done in probably 10 seconds with a for loop. Oops, sorry about it, but I'm just addicted to tidy syntax. This actually reminded me of a previous post on Mael's blog where she introduced us to the base R function. It might be from the tools package, I think, called modify list, which allows you to either change or add an element to a list really simply, as opposed to having to do all sorts of crazy assignment and square bracket referencing and things like that. So I was actually a little surprised that we didn't catch that in this blog post at all. I thought that might have fit partially into one of the functions that she touched on. So I'll have to dig into that a little bit deeper to see if that function would actually be useful. But if we want to do any data science, we usually have to convert the data we're given, such as a list like the one Mael starts with, into something rectangular like a data frame. And it reminds me of getting a JSON response back from an API and trying to wrestle it into a data frame. I think it's actually typically easier to go the other way, take data from a data frame and create a list, and it's harder to boil things downwards, in my opinion. And when I think of purr's reduce function, I'm typically thinking of supplying it with like a mathematical operator, such as the plus sign, to add up the elements in the same position across list objects. So I hadn't thought about passing non-mathematical functions to purrr reduce, but what a great use case here to boil down that list into a data frame. And it's certainly something that I've written a lot of nasty code to try to do, and haven't thought before about using the reduce function in that particular way, especially with these anonymous functions that we have access to. Now, I think it becomes very flexible, the syntax, to be able to reduce a list down into a data frame, and all the nuances that you'll have to deal with given the data that you're working with and how nuanced lists are in general. I think the ability to pass these anonymous functions into purrr reduce is going to make that whole process easier. So it's a great use case, something that I haven't seen blogged about a lot. So I really appreciate Mael taking the time to sort of point out this particular anecdotal example that's, I believe, something that we can all relate to, because as she says at the beginning, of the blog post, we don't typically get data to start out with in a nice format. We typically have to do some wrestling. And this code that she has here, I think, is going to help folks who are trying to wrestle lists into data frames.
Yeah, and that's the key, right? A lot of these newer opportunities or newer platforms to get our data from, typically coming from a service these days via APIs or another very hierarchical nested structure. It's great to see more examples of this in the wild, so to speak, because I admit I do spend a lot of time searching other people's code bases for how they wrangle that complicated structure. And the part I'm trying to get better at is a little more concise ways of creating these objects without a lot of intermediate stuff in between. Intermediate stuff's always great for debugging, but when you can kind of make it very compact, like this example here, I think then it's just a cleaner, more production ready kind of like, structure to your function that you can be confident that as code bases get updated, you can build maybe a unit test around it, and then you can kind of be done with it if you're all set and be confident that's going to stand the test of time for however long you want to keep that function going. So I think minimizing the amount of manual effort in this is a huge step. So reduce is another, like I said, hidden, maybe not so hidden gem, or just one that I didn't, put a lot of use in previously that I'm going to be keeping an eye on more closely in the future.
Definitely. It's funny you say that because in the comments underneath her blog post, someone commented, great, but unless you verify that the use of reduce significantly shrinks your runtime and or memory footprint, why bother in the first place? And Mael responds, to each their own, but in her case, it's often readability and therefore ease of maintenance, which is exactly what you're touching on right now, Eric. And I couldn't agree more.
Yeah, and this is inspired by me refactoring a production app that has been long in the tooth, and I'm thinking to myself, I know I did this for a reason, but I'm getting too lost in the code I wrote to understand it. So being more concise, business logic, intuitive functions, it's your friend. Maybe it's upfront work to understand these principles, but you can apply this in many different ways. It's not just for a single project. You could apply this in many different ways. And as you said, Mike, the opportunities to use something like reduce can be across the board on any operation where you're accumulating and updating certain parts of an existing base. I think this is a shoe-in for a technique that I think can level up anybody's our skills in the future.
Absolutely. And when you say we can apply this, all I could think of is we could L apply this. We could S apply this.
Oh, I get it.
All right. Well, I teased it at the outset. You could have fun, you all trying to reverse engineer where I live in the intro there, but we have a much more practical and frankly useful way to implement this information because, well, I'm happy to say that Andrew Heiss is back on the R Weekly Highlights once again, and it's actually a bit of continuity here as well because he is now covering a rabbit hole that he went under thanks to some of his students' questions on that aforementioned summer data visualization class he's been teaching as part of his curriculum. And this is a fun one, folks, because it takes a very novel visualization concept with large data sets and talks about the different rabbit holes you can go under to make this a very concise and impactful visualization in the world of maps. And what we're talking about here is that his summer class has the students complete a final project where they get to use real-world data and produce a storytelling-like visualization from it. Well, when you get real-world data, we're not talking about those nice little concise textbook example data sets you might get in your statistics textbook or mini tutorials. These data often are quite complex. And in one of his students' questions, they're using a very large data set to be superimposed as points of interest on a map. But they were dealing with many points to plot on a map, which then brings in the issues of overplotting, or maybe other terms for it. But what are some effective techniques to handle this from a mapping perspective? Because if you look at the world of two-dimensional visualizations, i.e. a scatter plot, when you have, continuous points, there are some great existing techniques available. Techniques like transparency, binning the points, and putting contours, kind of like a heat map structure. We have great techniques in the ggplot2 ecosystem to do that sort of thing. But how do you translate that into mapping visualization? Well, the good news is, and again, this is coming from somebody that does not deal with this side of visualization very much, the world of spatial mapping, there are great ways that you can take some of those concepts and fit in the use of other additional packages to replicate these techniques. And then Andrew goes through various options, applying this to an example of the state of Georgia and mapping all the different campgrounds on the site or on the map. And there are not a whole lot here, but he does this for illustration in terms of the points themselves. But you could do a situation that's pretty intuitive to a state map. States are broken down by counties, right? They have, their little mini boundaries inside the map. So you could color code that. And that's a pretty straightforward way to do with example code that he puts into the blog post here. And that's pretty effective already. Certainly better than dealing with potentially a lot of overfitting. Now, there may be a situation where maybe you're not as happy with the borders of the actual counties themselves. Maybe you want to do sub-regions that are more uniformly distributed. The second option is to create a grid superimposed on top of the state map and then use those as your groupings to quantify how prevalent these campground sites are. Again, a pretty effective visualization where you can see very clearly the brighter spots are in more of these central locations in Georgia. And then it gets potentially a little misleading on that approach, and that's where he introduces a third option, is a gradient superimposed based on the density of these points for the number of campgrounds. And that's where he leverages another package called SpatStat. Never heard of it before, but certainly am very interested to learn about this. He has many references in the blog post if you want to find out more that handle the calculus and mathematics needed to create these densities and then to be able to give you the tools to be able to take this object, convert it back to a spatial object, and then superimpose these densities onto the Georgia map. So there's code throughout this. You can run this all yourself just using the example in the blog post, but it gives a really concise and frankly pretty powerful visualization where now the gradients are more natural looking in context of what you might do in a two-dimensional display with traditional scatter plots and the like. So at the end, he compares these approaches side by side. And again, visualization can be a bit subjective sometimes, but I think it's pretty clear to me that the density approach does do a pretty nice, concise story to tell about the density of these campgrounds. And then Andrew closes off the post by doing a real overfitting example, in this case, a number of churches superimposed on the Georgia map, where you would definitely see a bunch of overfitting and overplotting if you just put these as points on the map. A whole lot of black blobs here compared to various segments of space of white on the plot. But then as you look at the gradient, you can superimpose these points very in a small radius, but then you see the colors showing the density of these churches where they're most concentrated by, and it gives intuitive insights in being more in the upper central region of Georgia once you do that gradient-based visualization. So it goes to tell you that you have multiple approaches to tackling this problem in a spatial context, and maybe one of those works better for you than others. But again, Andrew gives you 4 options to play with here, and I think it's pretty neat to be able to have these capabilities in the world of mapping that have become more standard in the areas of more classical two-dimensional visualization. So again, coming from somebody not an expert in spatial packages, there are tons of code examples here with references for you to learn more. And it's great to see Andrew documenting this rabbit hole that he went under trying to help this student out with their question here. And boy, I wish I lived at this time now in school, because then I would love to have a professor that turns my question into a blog post that I could look at in the future too. Those students are spoiled. I'm just going to say that. They have a great professor here. I can tell already.
It was awesome. Andrew starts by taking a simple scatter plot that has a ton of overlaid points that really just make these black clusters. So each point is colored black, that make it difficult to actually tell how much density is in that area, right? Because if you have 3 observations in your data set that have the same coordinate, they're going to get plotted in a scatter plot right on top of each other. So it's hard to know if that's 3 points on top of each other or 30 points on top of each other, right? And unless you're jittering your points, it's pretty impossible to tell. And that can make a big difference when you're trying to understand and visualize your data. So that's why he starts to introduce some of these other types of plots. He shows the same data then in a scatter plot with transparent points, which is, I think, a good start to trying to understand densities, but doesn't necessarily go all the way towards really gaining that full understanding until he starts to bin the points into square and hex points that are colored by density, sort of introducing that third dimension. And then lastly, he creates a full-blown density contour map that doesn't have any points at all. It has contours, and it's really beautiful. And it's nice to see all of the different options that we have when it comes to plotting this type of data. And especially when it comes to doing any machine learning, I think it's important to really understand the densities in your data. And it's really difficult to do that with a simple scatter plot. So introducing some of these other approaches, I think, goes such a long way. I remember, I think it was on an episode of Sliced with maybe David Robinson or Julia Silger or something like that, where they were using a baseball data set of pitches and trying to predict whether that pitch would be a strike or not, or a hit, I believe. And they actually sort of turned the strike zone into a density plot, and it was super, super cool. And it was really interesting to see sort of how that led to them being able to do some feature engineering that really went a long ways towards making the model as accurate predictively as possible. So I really appreciated that and find a lot of utility in Andrew's blog post, especially potentially when it comes to trying to do any machine learning or statistical modeling with data such as this. I've been deep down a geospatial rabbit hole, Eric, over the last few days. The United States Department of Agriculture posted some data on their website, sort of as zip files in these giant geospatial databases that I think ArcGIS or something like that exports 5 gig files that I was trying to read in. It's all about crop planting, historical crop planting all over the U.S. It's trying to read in, and it spun up, it started using like over 20 gigs of memory and crashed my machine. I got a couple blue screens.
Fun. Even better.
Yep. So that was really difficult. So ended up finding a Pythonic way to loop through that data and write it out to Parquet twice. And then we finally landed the data in Parquet files in an AWS S3 bucket partitioned by state. So now that they're in Parquet, they are so much easier to use, and that was sort of our goal, to be able to take the data that the USDA had published and make it useful for regular old folks maybe that aren't working on an HPC on their laptop, especially using that data in R. So anyways, needless to say, there is so much geospatial data in these files. And I will need to come back to Andrew's blog post, because I can just imagine that as soon as we go to start plotting that data, if we tried to do simple scatter plots for each point, there would be a ton of overplotting. So I imagine that we're going to be spinning up some density plots to try to show the utility of that data. So I will be right back at this blog post, and I appreciate Andrew taking the time to walk us through it.
Yeah, that's fascinating to hear the data adventures you're dealing with those agricultural data sets. Yeah, Feather is a very powerful technique, and that's a preview for those you might hear about in our Shiny workshop in the coming months, because we're big fans of being able to offload or finding highly performant ways of reading your data into your R session. And yeah, that is certainly one way to tackle that, and you even leverage the cloud to do it. So yeah, credit to use of multiple tech on that stack. That's awesome.
Honestly, trying to make the S3 bucket public was one of the hardest parts.
Isn't that always the case? Yeah, you don't want to hear about my rants about trying to get an S3 bucket even created in my org right now. So yeah, that's for another time, and they're not paying me enough money to rant about that here. So
Tales from the open source.
Yep, that is true. Well, we're going to stay on the visualization track. I'll be of a nice little fun way to introduce a little attribution to all those fancy visualizations and plots you're making with ggplot2. And in this highlight here, we have Nicola Rennie making a return to our weekly highlights, talking about her approach to putting some fun little social media icons on her latest visualizations as a neat way for the viewers of that visualization to get in touch with her on the various platforms. Now, there are multiple ways to do this, but Nicola's approach, as she talks about in her blog post, is actually going to the source of where these icons are, in this case, Font Awesome, getting the font files directly from their site, and then grabbing alongside those font files the actual Unicode symbols of these fonts, and then be able to plug that directly into the title or the subtitle of that visualization. But if you just did it there, you might notice a little bit of a problem. And her post shows this, but you see the text rendered in this very kind of cryptic HTML-like syntax. Well, of course, no one wants to see the verbatim HTML text of all this or the Unicode text of this. How do we get the nice little symbol in there, right? Well, we love callbacks on our weekly, so calling back to last week's coverage of the great ggplot2 kind of tricks and tips that were shared by the USGS group, there is a great package in the ecosystem called ggtext that will let you render HTML or Markdown-based text into a ggplot title or subtitle or label or what have you, and have it render as the actual display version of that text. So Nicola shows this in action in her blog post by adding a couple, I believe, a GitHub icon in her post, and it's very easy to implement with ggtext, and it is a great way to make sure that's rendered correctly. But again, a little fun along the way to spruce up your visualization, a little bit of visualization in the attribution itself. So very nice, concise post if you want to do those sort of things for your visualization. She mentioned she got inspiration from Tanya Shapiro, who's done this on her recent visualizations. A cool little fun way to put a little branding on your app without making people nauseous along the way with other corporate branding that we often see in our circles. So fun stuff from Nicola here. And yeah, I'll be doing that next time I try to make a viral plot for the online community.
Well, for the folks that do a lot of data viz work, especially like Tanya Shapiro, I believe that she's a data viz consultant. I think it's important for her to put social media handles and ways to contact her on the artwork or ggplots or whatever it is that is being published out in the open, so that folks can get in touch with her or whoever it is that's putting these plots together. So I've done that a couple times. I've made a beautiful post that, well, at least I think it's somewhat beautiful. My ggplot skills probably are not up to Tanya's or Nicola's for that matter. But I've put them out as marketing content, and it would have been great to have known this ahead of time so that folks could, follow on social or check out the GitHub link that lives behind the plot that I'm showing. So it looks like it's pretty simple with the ggtext package. There's just one function that you can add to ggplot's theme argument, element text box simple. You supply that to the plot caption argument of the theme function of ggplot. And essentially, it takes that kind of nasty HTML-looking code that encapsulates the Unicode character and just prints out the nice GitHub icon in Nicola's case, as well as her GitHub username at the bottom left corner of the plot. And, you said she got inspiration from Tanya. She also mentions a couple additional resources, one being Albert Rapp has an excellent blog post on using fonts and icons with ggplot2. So I'm a big fan of data viz, as you know, Eric, and any little improvement that you can make to try to make maybe your ggplots not necessarily look like ggplots, like we try to do with Shiny and a lot of other things, I think can go a long way towards creating something that really captures the audience's attention.
And the best part is you can all do this within ggplot itself. And you know me, I'm a bit of a cheapskate, so to speak. I don't want to pay Adobe all those outrageous license fees for Illustrator or Photoshop or all that. But in the case of this, if I can put these nice, neatly rendered icons, maybe a custom font along the way, you can get probably as far as you need, I would say 99% of the time with the tooling we have available to really make these visualizations and the stories you want to tell with visualization really pop and stand out without showing the big bucks for this proprietary software. Because you know me, I love open source all the way.
Open source all the way.
What else is open source, folks? It's our weekly itself, because you see the source of each issue on GitHub and our version control repository. But this is a time we'll get to how you can help the project a little bit, but we're going to take a chance to talk about the additional content that Tony's put together for us on this issue. And speaking of making things friendly for users, so to speak, it's a package we talk about quite a bit on our weekly, but GT has yet had another update. But this update is not so much for the functionality of the package itself, but Rich Ioni and the team have done a tremendous job updating the user-facing documentation, really consolidating the over 150 functions that are exported by GT into, I would say, logical themes or categorization, and for you to quickly know what is, quote unquote, a required parameter versus some of those that are more optional for maybe styling or other aesthetic considerations. And I'm very happy about this, because I was actually using this earlier last week on a rabbit hole of my own. So buckle up, listeners. A little bonus story time of our podcast, baby. If you listen to my live stream, you know where that came from. But I'm actually doing a new fitness routine, and I'm keeping track of the various exercises and weights I'm doing in this routine. The book I bought that kind of gave me inspiration for this, the author actually shared a Google Sheet of the different workout variations and the number of reps he recommends for these different exercises. And I thought, well, I want to keep track of this, but that spreadsheet, not my style. But guess what? It's a Google Sheet. It's a spreadsheet layout. I'm going to use R to ingest that spreadsheet, and I'm going to use that as my metadata, and then create, in essence, a standard form for these routines where I can take it to the gym, fill in my reps and number of weight I did. And yes, I use GT to make that form. Yes, I have over-engineered my workout routine with R. You're welcome, folks. I will put that on GitHub sometime when I polish it up, but I literally just had the 54 weeks of entries printed at the local FedEx here that I picked up yesterday. So GT gave me a polished data entry form for my workouts. I don't know how anybody can top that. Good luck.
I would expect nothing less from you, Eric. That's an incredible story. And I also did see the updates to GT that in documentation, especially. It's awesome. One thing I did notice, it looks like the code formatter that was used to render that documentation treats your base pipes, I imagine, as little right arrows, which is pretty cool. It looks
I wonder if that's coming from
nice.
The Fire font or something like that. That's really neat. Yep.
Yeah. So awesome updates always to the GT package. One other blog that I wanted to call out that I thought was really interesting was by W. Joel Schneider. It's called Annotated Equations in ggplot2, and it's about importing LaTeX into ggplot2. And essentially, it's a pretty small blog post, but it shows how to essentially create an image in LaTeX. And in this case, it's the equation for calculating a z-score. And then each element of that particular equation has a little arrow pointing to it, and with a description of what that element represents. So like the mu in that equation represents the population mean, and there's a nice arrow that points to the mu and says population mean. And there's a lot of different colors going on here as well. And the LaTeX to create that is not too bad. All the code is here in the blog post. And essentially, the output is a histogram with this nicely annotated LaTeX equation to the right of it, all on a single plot. And I think it really goes a long way towards sort of explaining what is going on, explaining statistical concepts potentially to new users, all in one particular place. And just seeing a formula sometimes, and then way below it, maybe the definitions of what each element of that formula represents, can be perhaps a little disjointed and tough to tie the concepts together. But when you have literally the arrows pointing right to every element in the formula on screen right next to the plot that it's describing, I think it really, really just lends itself to ease of understanding, especially for newcomers to concepts. So if you're somebody who's teaching mathematical concepts using R and LaTeX, I think this will be right up your alley.
Yeah, this would have been super handy if when I was doing in my grad school, I had one semester I was asked to be a TA of an intro stats course. I tried to use R for most of it, but boy, the ecosystem wasn't nearly like it is now. This would have been great for teaching the normal distribution or these other esoteric distributions that we often had to illustrate with. Yeah, another great example of just how much power you can bring into your ggplot2 visualization. A little friendly math notation for all you statistics majors or minors out there taking these courses. Yeah, it's a great way to make that visualization pop even more.
Z-score equation isn't too bad.
It could be worse, yeah. Just you don't want to see my dissertation when I had to do the lit review of convergence and martingale theory for competing risk methodology. Yeah, that puts the Z-score as you'll appreciate it more after that.
No, I don't want to see it. Thank you.
No. And good thing is audio, because otherwise I would subject you to that. But in any event, we're not going to subject you to any more rants about distributions. We're going to tell you that our weekly is a project by the community and for the community, and it does not keep the lights on without your help. And the best way to do that is to get in touch with us. If you find a great blog post, a great tutorial out there, heck, even another podcast or video that you find that's useful for the community, send that to us, and you can do that via a pull request to the upcoming draft of the next issue. It's very easy, all marked down all the time, and we're happy to get that merged into the upcoming issue. We have a broad selection of categories, and there's always something for everybody in each issue. And if you want to get in touch with us directly, you have a couple ways of doing that. We have a contact page directly linked in this episode show notes that you can go to and send us your feedback. You can also, if you're running one of those cool modern podcast apps like Podverse or Fountain or Cast-O-Matic, you can send us a little boost along the way, or you can send us a boost directly on the podcast index itself, where we'll have a link to in the show notes as well. And also, we are sporadically on social media. Do I take a stab at calling it what I think it should be called? I don't really care. It's what you used to know as Twitter. I'm sporadically on that with @TheRcast. But honestly, I feel more comfortable now being on Mastodon these days, where I am @RPodcast, @podcastindex.social. And that reminds me, in this issue, there is another highlight or another post about somebody taking their Mastodon data actually offline for processing in R. So Mastodon gives you a way to access that a lot more easier than have to pay the big bucks to you-know-who to get that other platform's data. But anyway, that's how to get a hold of me. Mike, how can the listeners find you?
I'm just going to throw out Mastodon because that's where I'm mostly at these days. It's Mike_Thomas @fastodon.org.
Nice and clean. I like it that way. And jokes aside about other platforms, at least we keep it pretty clean on this podcast, although if you listen to the pre-show, that might be a different story. But that's another story for another day. But in any event, we're going to wrap up episode 131 of our weekly highlights, and we will be back with another episode for episode 132 next week.